Good evening. This is Team 67. We are doing inventory management system. For our table of content, we have our project topic and objective. We have our team responsibilities, functionalities, flowchart, and our demonstration. For topic and objective, for our topic, we choose is inventory management system so that we could perform the CRUD operations on products so that they could manage the warehouse operations. So we know that business will struggle at managing traditional business especially will struggle at managing product availability. It's hard to scale when you have hundreds or thousands of products, and each of those items they also have their own quantity too. So it'll be hard to manage all of them. So our solution is to use the various data structure that we have learned to build a unified system that allows business to manage, maintain, and track and could completely control their inventory. For team responsibility, we have Van Heng doing stack and queue, Heinrich doing merge sort and vector, myself doing single linked list and double linked list, Sun Karo does hash table and tree. So for its functionality, first we have unified menu via enum of menu state. So we have a lot of menu state. Others will explain this. You can list inventory by attributes via merge sort. I will explain this shortly, and others will too. All products are stored in a double linked list. So all the CRUD operations will be done by the double linked list, and the hash table is a open hash that uses single linked list. We have restocking item using queue, tree to filter a range of price, and we also have stack to undo an action. So this is our flowchart to get a rough idea before we go forward. When we start the program, the main function will call a function that load data from the CSV, and then it will display the menu. I will explain from top to bottom. First one is view list menu. So you can choose to view the item by sorting by ID, name, price, or quantity. This is using the merge sort function and sorting 4 different ways. Secondly, we have add item and save, update item. So add item, obviously, when you click on it, it will prompt you for the necessary values for the product. And for update item, similar to add item by just updating. For remove item, you remove item via using ID, just type in the ID and it will remove it. 5 and 6. So restocking means you're adding product into the warehouse. So we are a warehouse, and order item is when you take product out from the warehouse. So for restock menu, we can restock by ID, auto restock queue, and display low stock item. This will be explained by others. Order item and save. So you just add the ID, the amount, and it will take out the item. Number 7, undo last action and save. So let's say you perform an update previously, and then you perform a remove, but you regret the remove. So once you press 7, since the remove is the last action, it will undo the remove, so the item will be there still. Now if you press 7 again, it will also undo the update. But if you just load the program, you do not, it's a clean slate, you didn't do anything yet, the undo button will not do anything. Number 8 is filtered by price range using the tree data structure, and 0 is to quit and save to CSV. So once you quit, everything in the double linked list will be saved into the CSV file. Now, since I explained the general view, for the next part, each of our team members will present individually.
My name is Rachan Kotbot. I am the person responsible for double linked list and single linked list.
Now, before moving forward, I would like to explain some part of the main menu first. So here we have menu state related to the stack function that is able for us this much able to go back and forth within our views. These three are for our undo stack or undo an action, and the rest is also for the menu displaying the menu. This is where we initialize all our data structures: hash table, double linked list, vector, stack, restock using queue, and then we have the reload function. You can see that the reload function will clear the vector, the list, the table, and the price tree. Now, the reason we have the reload function, I wanted to explain especially this part. Let's take for example when we update an item with how we did it. We enter an ID, is search, is the product exists. So if the product exists, it records the state for undoing it, and then you will be able to update the item, of course, and then we save it to the CSV. Now, because we also have to save it to the vector and to the hash table and such, we just save it to the CSV, and then we reload everything back from the CSV into the hash table, into the double linked list, and everything else. That's the reason we use reload, except for the part where we had to add an item. We only append it. We only append to the CSV and we insert the node through the table and such. Now moving on to my part especially. I created two structs for the node or the element. We had the element 2, which is for the double linked list. It has 2 pointers, and the product data, which we define here, where it has an ID, a name, a quantity, and price. Now going back, for this element, it is responsible. The reason I have it is because we need to implement a single linked list inside the hash table, because our hash table was if I remember right, it was called an open table, and yeah, and this is where the double linked list, where we initial blueprint for the double linked list, our constructor, our destructor to prevent memory leak, clearing the list for the reloading function and for ending the program, get head and get size, so it could be called elsewhere using various data structure. We have the add function, of course, the remove, and display. Yeah, and that's about it for my part, where you can also, if you go through the hash table, you can see how it will be, how we implement the single linked list into the hash table, but that is not my part. It will be Kato part, so he will explain that. Thank you, and on to my next teammate.
Hello everyone, my name is Van Heng, and today I'll be covering Stack and Queue. So let's just start with Stack here. We got an enum class called action that contains the type of action that will be performing on the product. So we got a structure state here that just stores them, like action type and the product state before and after. So moving on to the main class here, since we're doing a stack as a array, we have the static max size of 100, and we initialize here. We just initialize the stack here, and we create two booleans here to check if the stack is empty or is full. So we have So we would create a function to push the data into the stack. So we first would check if the stack is full. If it is full, we would just display this message, and we would ask the user if you want to get rid of the oldest history for the newest history. So if the user says yes, we would do that. We would increment, we would change the number to be lowered by one index and erase the oldest element. And so we have spot for the newest his element, which is the newest history. So moving on to main C++ here, we have this handler function called handle undo. It would ask us first if the stack is empty. If it is empty, it would just display here and it would just return back to the menu. So here we also got a local variable here that actually contains a snapshot of the before and after of the data. So we would have condition here where if the action, the type of action it is, the type of, and then we would perform the undo feature. So let's start first with this action type here, where we have add function. We would simply just remove the nodes and we just display the message here. So if the action type is update here, we would search through the table, the linked list table, and we would, since we have the copy of the data before, we would just put it to the data before. Since it's an update, we would overwrite the old data to be precise. So we would just display message afterward. Same thing with remove here, the action type remove here, where we would just, since we have a copy of the old one, we simply just need to add back the nodes of the old one and just display here. And we would just write to the CSV here and reload it. And if we were to check the view list function, it would just display it for us to see. I will display the undo display. It should go back to what it was originally before doing anything to it. Okay, moving on to queue. Here we got queue as a linked list. So we need to create a node for the queue which contains the product data and the pointer to the next node. So we also got this class here called restock that has the pointer to the front and the rear of the queue. We also got this tool method here that for checking the size, for getting the size and checking if the queue is empty or not. And we also got this method here, this tool method here. One is for on queuing, is for inserting the product into the queue and then reassign the old rear to the next pointer. And if there's nothing on beside the element being inserted, the rear and front is the same thing, assigned to the same element. So we have dequeuing where it find the front, the pointer to the front, and would just remove it, just deleted the front. And moving on to our main here, we have a handler function where we handle auto restock here, where it would have a low count integer which tracks the item that have a quantity less than 5, where we scan the vector list here from vector developed by Heinrich of the product and insert it to the queue, where we can approve and enter a new quantity here will update in the CSV folder to the new quantity that we wrote here. So this is just to check if the quantity we put are less than 0, because you cannot put negative in a when restocking. And also we came to here, this method here, handle restock by ID, where instead of automating the restock, we can restock individual item, where for example apple we need more than 10, but we already got more than 5, so the system won't detect it. So we could just type the ID, and we could type the ID in here, where we could go straight to the pointer and change and update it from there. Now that's it for Q, and Carol will be the next presenter for hash table.
Hello, I'm Carol, and I'll be doing the explanation for hash table and also tree. Let's start with hash table. Here, as you can see, is the file implementation that I wrote. We have the private attributes for the table size and also the pointer variable to the elements of pointers. Array of element pointers, and also the hash function. Following is the default constructor that we have that initialize the default value, the destructor to destroy the hash table object, the initialization function that we use to store all of our product object in memory as pointers in our singly linked list of the hash table array indexes, so that we can randomly access them, which is the whole point of our implementation. This is our insert function, where it's just a basic singly linked list operation. This is the clean function, where we use to destroy every node pointers inside our array. And finally, it's the search function, which is the whole reason why we choose to write hash table in the first place. If we were to look in the implementation, there are many places where it is implemented. Handle update item, remove item, restock auto, restock by ID, order by ID, and undo. This is because we can randomly access the product location in memory much more efficiently than if it was to do a linear scan of the whole product from the doubly linked list. And that's it for hash table, and now we will move on to tree. So this is the implementation for the tree. We have, as you can see here, we have a structure of tree nodes, which has the data pointer to our product, the left and right of our tree node pointer, a default constructor. But also here we actually have our implementation of our tree. First, we have our root. We have the clear function that cleans recursively of our tree nodes. We also have the insert function, which is also a recursive function that follows the left-right data. The range search is also a recursive function, but instead of left-right data, we follow the left data right. As it moves left, as it reaches the leaf, it will print out data. And here, it will move right after it prints out our data. In the public attributes, there are the default constructor that sets our root to null, our function insert that calls upon insert, which takes in root in addition to our pointer product. We also have range search of min price and max price, printing the header and also calling upon range search. The clear function that cleans recursively, following the left-right data algorithm too, and also it sets root to null. As also, finally, we have the load function. In this load function, we use it to initialize our tree, which is called in the reload function, and also the main function under price tree dot load. And that's it for tree. So now Heinrich will explain vector and merge sort along with his demonstration of the program.
Hello, my name is Heinrich, and I will be covering vector, merge sort, and the demonstration of the program. So here we have a template type name T, and we created here so that we can create a vector object that is able to store any type of data. So it will be something like this. So we use something like this inside our program. The product here is our product, and now let's go for the implementation. So we have the capacity used and the data itself. So a vector, when you create it, it has the constructor, and it will create an array of that data type of the size of 1. So we have the set the capacity to 1 and use to 0. So now is when you push back an item, like add it into the vector, it will check if the capacity is equal to the used, and if it is, it will call the increase size, and here increase size. So it will multiply the current capacity by 2, and will create a new array with the new data type, with the same data type, and the new size, new capacity. And afterwards it will loop through all the available old data and copy it into the new one, and afterwards it will delete the old data, and then afterwards it will update the data to the new array, and this here is a pointer. And now we have the operator, so we can use something like the object and 1, something like that. And now we have the size, begin, end, and size is just added here so that we can use for each loop for our vector object. And here this is a custom display for our vector. We use this display after we merge sort usually inside our program. So we'll loop through all of the available vector and we'll display it out for you. And now we have the load function. It will load the W linked list into the vector and get available ID. So inside the add item inside our program, it will not ask for the user inputting a specific ID for a product. It will just find the next available ID, and then it will create it along with that ID. So that's all for vector. Now for merge sort. So this is no different than a regular merge sort implementation, but we are able to sort a specific field of our product. So we can sort it by the ID, name, quantity, and price. So we pass in the left product and then the right product, and then we compare the product.id, ID, name, quantity, and price, and then it will return a boolean. So that's how we compare, and let's see how we use it. So we call merge sort, and then we pass in the vector. This is the vector that we implemented. And now for this special one is how we filter by fields. So we pass in on the right side, we'll pass in the function name. So compare here will be this function name will be ID by name, quantity, or price. So we pass it in. So normal sort, cut the array by half and then put to the left to right, fill it up, and then we send the compare into the itself again and into the merge. So the merge will accept it, and then it will use it inside the comparison. So if this is true, it will assign it accordingly. So in this assigning like this, it results in a descending order. So here's how the merge sort is used inside the program along with the vector. So we see here by the merge sort, and we go here. So in every single filter is by the ID, name, price, quantity. It's always call the function, pass in the vector, and then vector display. And this happens to all of them. And for the handle restock display, it also uses the merge sort and it will display by the quantity first. Then after it sorts, it will loop through. As we can see, as we remember, it will display the one that is below 5. So as we know, the vector is already sorted by quantity, so we just loop until it meets the number 5, and then it just breaks. Okay, so that's how a merge sort is used inside our program. So that's all for merge sort. Now for our program demonstration. So as I explained, viewList, it uses merge sort and then it uses the vector.display. So we are able to sort at different product field. And so we do one, we have sort by descending order, ID and name, price and quantity. Now let's go back. Now for add item. So we have, let's say we want to add, it should append to the bottom of the CSV. So add iPhone, price, whatever, 100. So you can see here it appeared. So now let's update the item. So we see here with the get available ID, it assign an ID for the phone one, and you see here a program found iPhone, and then we can rename it to okay. So you see here it got updated to phone, and now let's remove the item. One, it deleted the phone for the quantity of this much. And before we go to the number 5, show you the undo. We can see here, we'll put it back, and then we can undo again, and we can see here, and we can undo again to here. Yes, it stopped it from creating. Okay, so it also says what action you did. Now for the number 5. Number 5, it will queue all of this object as long as the quantity is below 5. Let's see if we have any. We do not. So let's edit some. 2, 1, 3, 1, 1, I guess. Okay. Now let's do the review stop. So now if we display the item, it shall see that the item that is needed to restock, which is the mango, apple, orange, and grape. And so all of these are added into queue, so they're in a queue of 4. And now let's auto restock. Auto restock here, it doesn't automatically restock everything, it just starts the queue so that the user can restock the item. So the restock the item, it does not like overwrite the old stock into the new one, but rather adding on top of it, so it'll be like addition. So we have quantity of 1, so we add 10, it should be 11. So 10 everything. So you see here on the top, we added 10 for all of them. Okay, so now let's do the restock by ID. So restock by ID is no different from a update item, not that much different. Instead, it will just say, let's look at tissue 23. So 23. So the update item, it will override the old one with the new stock, but this one it will just add to it. So you see here, add 1,000 to the tissue instead of only setting it to 1,000 like the update item. Okay, now let's go back. Now we can order the item. Order. So let's say you want to order a tissue again. Order here, it just deducts the quantity. That's all it does. Yeah. So it's back to 185. And of course, you can undo them. Undo. Fancy. Okay, number 8. So it will display us a range of price. So like 20 to 50. Now we only display the object that is within the range of price. We don't have the implementation to filter by the quantity. So now it's just the price. Okay, so that's all for the program. So I'll explain a little more about everything. So view list, it uses the vector and merge sort for its function, and the add item, it will use the hash table. Wait, so all of this use hash table. Actually, probably all of them. As long as they're searching for a specific node, it will use hash table. And for the review restock, it uses queue. The undo, it uses stack. And then the filter by range, it uses tree. And also the menu going in and out like this, like in out, and this, oh whoops, the menu navigation going down and down, back, it uses navigation. It uses stack. And that is all for our program demonstration, and thank you. Cut that out.